In this series, What Quantum Science Taught Us About Being Human, I've been trying to convince you that since the evolution time of Homo sapiens is insignificant compared to the long existence of the universe, our human faculties must be but manifestations of underlying common qualities of all that exists. In part 1 of the segment Universal Intelligence, I explained that when stripped to the very essentials, intelligence is the ability to connect two events, and that all entities, living or lifeless, do this when, after connecting with one event, a change in their propensity prompts them to connect with another event, thus resulting in the two external events becoming entangled. We, humans, do this in exactly the same way as everything else, by having a body that, as a quantum system, emits and absorbs energy waves, and by having intentions, our human way to use propensities to achieve particular ends. I also explained that intelligence requires perseverance, and that quantum scientists developed a way to discover that particles at quantum levels demonstrate perseverance when engaging in repeated probing to be able to entangle with other particles. This was studied under the odd name of the quantum Zeno effect, the underlying common quality of having motivational feelings. If one is convinced that intelligence is a common universal attribute, we can move forward to explain what at first glance may appear to be impossible or even nonsense. How do brainless entities use their intelligence? You will be surprised to know that a biological brain is not the only brain. What really is a brain? Simply defined, a brain is an organ that controls functions. So how did this controlling center evolve? Let's have a look at brain evolution with a simple analogy. Consider a small group of 4 people playing tennis on a weekly basis. The arrangements are simple. One person books the court and collects the money for hiring it, and others are happy just to pay and play. Although it may not be appropriate to call the person hiring the courts the brain of the group, it would certainly be suitable to say that this person is in charge of a particular organizational task. Suppose that other interested players join in, and that the group grows to involve 20 players. There are now more tasks involved: booking more days, arranging the teams, different venues, and perhaps an internal competition. As a result, the men and women in the group form a rudimentary committee to delegate tasks and manage the events. You have just witnessed the evolution of a simple brain functioning at a social level, the formation of a managing center, the committee, consisting of interrelated entities, committee members, making decisions to regulate the body, the players, managing the group, and arranging events and venues. The analogy with a biological brain is straightforward. The brain is a controlling center of a nervous system, the committee, with interconnected nerve tissue, the committee members, connected with the body, the players, in charge of generating thoughts and strategies to manage the functioning of the body and its needs, events and venues. It is safe to say that a rudimentary brain function exists in every group of interactive entities, whether these entities are people or not. This is the case because by taking charge of particular functions when interacting, different members in the interaction influence the state and behaviors of other members. The brain is a sophisticated nerve network doing just this to manage interactions. Let's return for a moment to the person in charge of booking the tennis court in the group of 4 tennis players. The action this person performs constitutes elementary brain functioning for the simple reason that this is part of managing the events and what the players do. We don't see any nerve system here, but what we do see is brain activity with a different type of controlling mechanism. What this example shows is that organisms that do not possess a nerve system are not really brainless in the sense that they do have an internal controlling mechanism. The biological brain is therefore not a new process, but a transition from one type of controlling mechanism to another one involving neuronal conductivity. Early life on Earth, approximately 4 billion years ago, was dominated by prokaryotes, unicellular organisms with no nucleus. But their dominance was challenged approximately 1 billion years ago, when phagocytes who fed by engulfing and digesting debris and invading bacteria formed a mutually beneficial association with some of the bacteria they ate. A new species emerged from the union, eukaryotes. It was as if a large number of new members joined the tennis group in the analogy. And just like they needed a committee, eukaryotes needed a brain to assist them manage the more complex physiology. They evolved a structure resembling a proto-brain, a nucleus, allowing them to attend to more complex tasks in a more developed body. The tennis players in the analogy just formed a rudimentary tennis club. This gave origin to brain neurons. Neurons evolved because of the need to manage increasingly more amount of information, as if with more tennis players, the tennis club in the example needed some office equipment and perhaps a receptionist. The equipment allowed them to perform tasks more rapidly, and it was also the need for faster transfer of information what transformed existing cells into neurons. The membrane of previously existing cells allowed a small electrical potential caused by the difference in chemical composition between the inside and the outside, which they used to communicate with their surroundings. With the new demands, this communication needed enhancing, and this occurred when disturbances in the membrane caused some membrane areas to lose their electrical potential, becoming depolarized, losing their polarity at the disturbed sites. Additional depolarizations facilitated electrochemical information to travel quicker from cell to cell, and a proto-nervous system was on course. The first proper brain was but a more advanced result of this process. These are processes based on the evolution of physiology, but how do quantum principles explain these processes? In particular, how the brain evolved from brainless organisms. All the quantum principles covered so far have a role to play in these rationalizations. Let's consider the ability of quantum systems to emit and absorb energy and display propensity to acquire certain states. What was needed, which was the implicit propensity, was to expedite communication between different parts of the physiology, and as usual, organisms could only resort to existing mechanisms and adapt them to the new task. The intrinsic wish was to put mechanisms already in place to new use, and the best way was to use existing specialized cells capable of transferring information throughout the body faster than normal cells. These cells would be the precursor of the nerve system. By emitting quantum energy, carrying this propensity to the sea of probabilities, brainless organisms started to reproduce into copies of themselves with more evolved characteristics, allowing for faster processing of information. A propensity that is an intrinsic intention to develop faster communication systems led brainless organisms to develop a brain. But how did they do that? The answer is by emitting energy waves, carrying this propensity into the quantum sea of probabilities. The ability to emit and match energy waves is the most elementary mechanism in the construction of physical reality, and all quantum systems do that by assembling potential templates of reality in this soup of quantum probabilities or potentialities. You may recall that, like molecules, all organisms exist in multiple potential copies or as probabilities. When the energy that an organism discharges matches the energy of a potential copy of these organisms in the state of this propensity, repeated probing holds this copy in place, slowing it down to below the speed of light, which can then be perceived with physical senses. In this manner, brainless organisms with a propensity to generate a faster internal communication system managed to gradually assemble potential templates of reality where they existed with an important characteristic: to use calcium, a raw material available in the surroundings, to interconnect faster with their internal components, a mechanism that is still part of how neurons communicate with each other in the modern brain. A quantum system displays intelligence by connecting external events. But it takes highly specialized systems to do this at high levels, connecting many pairs of events together and rapidly, like the brain. Our human body is not so highly specialized in intelligent tasks. So why are we so intelligent compared with other creatures? Because in the course of evolution, our propensity has been to download a brain that can give us the ability to think logically and act rationally. But the brain is a quantum system in itself, and although it is part of the body, it is not our consciousness. To put it differently, we have a brain, but we are not the brain. Just like eukaryotes needed a brain to assist them manage the complex physiology, we need a brain that can help us achieve our technological advances. Our brain is a tool that we use to advance technologically. Therefore, it is not really us who are intelligent, but our brains. We use other tools to assist us cognitively: calculators for complex mathematics, computers to process data. And in the same manner as we are not the computer or the calculator, we are not the brain. The quantum process that we use to evolve with an intelligent brain is the same as eukaryotes used to develop a nucleus leading to a proto-brain, by having intentions. When we want to devise the next generation of Android phone, send a probe to Jupiter, or manufacture a more friendly user computer, these intentions are the energy waves that we send to the quantum sea of potentialities, where we assemble these probabilities into potential templates of reality. Every time we see a new achievement, it is because we have succeeded in connecting with and slowing down these potential events to below the speed of light, thus becoming our reality. Recapping on previous episodes, I mentioned that our human faculties must be manifestations of underlying qualities common to all that exists. Intelligence, for example, is the common universal ability to connect to events. Guided by a propensity, all systems, including a human body, emit energy waves, probing repeatedly the quantum sea of probabilities for potential events that can match these waves. I said that the brain can be defined simply as an organ that controls functions, and that these functions are comparable to social actions such as managing a group of tennis players. Each component in the system is in charge of a particular organizational task. Both a biological brain and the social group can be seen as controlling centers, one by a nervous system and the other by having a committee and members. At rudimentary levels, brain functioning exists in every group of interactive entities. The brain is a sophisticated nerve network doing just this to manage interactions. The evolution of the brain stems from the ability of unicellular organisms to develop a nucleus, which then led to a proto-brain and the modern brain. I explained how these processes is analogous to how a small group of tennis players can develop into a tennis club by learning to manage larger amounts of information. I described briefly the quantum principles responsible for this evolution. The most important is the ability of all systems to emit and match energy waves following propensities to probe the quantum sea of probabilities. Persistent probing allows all entities to connect with copies that exist in potentiality in the required state and slow down the states of these copies, thus transforming them into physical form. I mentioned that probing the sea of quantum potentialities allows us to generate potential templates of reality. In the next episode, I will be addressing the deep quantum mechanisms responsible for transforming our intentions and wishes into potential templates of reality, and how we collapse the wave function of these templates to create our reality. You will notice that events in our lives are the result of the thoughts that we entertain, transformed in the intentions that we feel.